Hi do-it-yourselfers, welcome to Geek Do-It-Yourself Mechanic. This case study is going to be about a Turbo 85 RX-7. It's a Phoenix. Hopefully you'll be able to figure out why I named it that. Little background on the car. This is going to be a different case study. I'm going to give you a little background that makes the story more rich. This is an RX-7. Clearly an RX-7 is a Wankel type motor. In this case, in his car, he had two rotors, and each rotor has two plugs, and it's much different than a four-stroke. Maybe I'll do another video on that. But in theory, this should have been the dominant sort of engine in cars, but it has issues, pros and cons. That isn't what this video is about. But anyway, that's what that engine looks like, whereas we're all used to the pistons going up and down. His car was far from stock. It was customized by Company A. Don't want to say the company. Neither company names matter, as you'll see. It was turbocharged, has a custom tune, and being an 85, it clearly doesn't fulfill the OBD2 standard. This has a sad part to this story. It had an engine fire due to a poor fitting fuel line connector. And then it was rebuilt by a company that we shall call B. So viewer discretion is advised. If you're a car lover, you're not gonna like this part of the story. So here it comes. So if you don't like seeing nice cars on fire, I suggest turning away until I say you can turn back. There she is. The hood is on fire. Don't know how my friend had his wits to take pictures. Maybe someone else took it. I would be too busy crying and panicking. There's the fire truck that finally put it out. I guess the good side is the whole car didn't go. As you can tell, it appears it stayed local to the engine bay. Here's pictures of the engine bay. That's the passenger side. Clearly all the hoses and air filter and the wiring harnesses are shot. Wow, that's a lot of work. Plus paint. You can see paint is ruined. This is that's the, again, passenger side firewall. All those wires are just toast. It's sad. You can look again to all those with the not so strong stomachs. We're now on the nice pictures of the car. Can you believe it? Company B, Shop B, however you want to call it, they did a great job. That looks pretty good. This is the driver's side. It looks incredible, doesn't it? All those wires look good. He's happy. It's all good. A little about my friend. He loves his car. He has a very good understanding of cars. He's an electrical engineer. And he's had several mechanics look at his car resolving his issue. You're probably wondering what the issue was. Before we get there, did anyone notice something about the intake manifold? I'll let you look, see if you see it. Ooh, what's that? That's right. It's missing. On the rebuild, that ground wire is not going to the intake. And he does have some other issues, some instrumentation issues that I'm speculating could be this. But maybe that's in another video. I think he's going to take care of that himself. I'd love to work with him on that, but I think he's going to take care of it himself. Okay, what was the issue? Intermittent misfires. Sometimes he experienced poor idle quality. So he decided to involve me, and so I talked to him, and I went into the data gathering phase of my debugging I knew going in intermittent issues are tough, but he was experiencing them more and more. So they're becoming, almost hard failures, one could say. They were becoming so prevalent. My friend is extremely observant, had a great memory. So whenever I would ask him, he gave a great picture and could almost tell the condition. He almost knew the weather. Crazy memory this my friend has. So we talked to gather the data points. Here's what we gathered. Before the fire, the car never misfired. So we knew the last time the car was good. After the rebuild, he really had to dig in his memory, but he remembers the mechanic telling him that the mechanic had this issue moving the car from the engine bay to the parking lot. But then it went away, so they sort of, dismissed it. We've all done that, right? You're working on a car, something acts weird, and it goes away, so you're like, oh, okay. Anyway, that was the beginning, though. He remembered that. What a memory. There was no check engine light. Would happen in all types of weather. You'll see why that matters, dry or rain, at least to me. Would happen cruising or accelerating. Was intermittent, but was happening more and more. So much that he was almost scared to drive his car. And he loves his car. He wants to drive it, right? It's like a nightmare situation. When it would happen, sometimes he'd pull over and he would just touch the wiring harness and it would go away. His car clearly wasn't in stock form, so the wiring differed from the wire diagrams in the shop manual. So my angle of attack, all this was over the phone, by the way. So I was just sitting at home thinking, what am I going to do? So I studied the wiring diagrams to determine the ignition circuit type. We'll go over that in a second, if it was a pull-up or pull-down. You'll see why I care about that. I reviewed the shop manual, but again, that didn't necessarily match his car, but it couldn't be drastically different. It isn't like you put a Chevy 350 in it. It still was a rotary. The PCM had to control both spark plugs per rotor. There were 4, and there were 4 coils. And on the stock one, there were only 2 coils. And then, because once I determined the tests I was going to run, I knew what tools to bring to his house. So when I heard he was burning through coils, meaning a mechanic found that coils were going bad, I thought maybe the control wire, that's the wire from the PCM to the coil controlling the primary, turning the primary on and off to have the secondary fire or ignite, was being shorted. If you remember 2000 Focus I worked on, I have a video on that. That was the case. It was a pull down type circuit. So I was thinking maybe that was it. But to know for sure, I didn't want to assume. I wanted to look at his wiring diagrams and determine if his ignition system was a pull up or pull down. So real quick, just to remind you guys what I mean by pull up and pull down, let's look at a circuit and I'll refresh your memory. So this is a classic circuit, right? Remember, it's a circuit means circle. So you have your power source here. We have one switch before the load. The load can be anything. Could be the coil, could be a starter, could be a light, whatever. And then a switch after. Well, there's the difference. So depending on where you control it, where you switch this load, indicates if it's a pull-up or pull-down type of circuit. So in this case, if you look at these two monitors down here, sort of like a scope, right? Test point 1 is right here before the load. Test point 2 is after the load. So a lot of times you may back probe, let's say, the ignition coil like I did, or it could be the motor or starter or whatever. So that's why I did it like this. Usually you have at least 2 lines going in and you back probe it. So on the front part, when it's everything is closed, it's at 12 volts. And after, due to, as we all know, all the Kirchhoff's law, hope I said that name right, all the voltage will be consumed by the load. Remember that in one of my other videos. So it's at 0. Well, what happens to test point 1 when I switch it before the load? It goes down, right? So if I have my test probe there, all right, back probe right there, and the control is off, it's low. So what happens when I turn it on? What's going to happen? It's going to be pulled up to 12 volts. See that? Off, on, off, on. So that is a pull up type. So what that means is power is being switched on and off to the load. Well, let's go conversely to the pull down side. So at test point 2, when it's flowing, it's at 0. The potential is 0 because the load is consuming all the voltage. So let's open it. What happens? It's at 12 volts. Both sides, test point 1 and test point 2, are at 12 volts. So when I click it, it's a pull down type circuit. See, it's at 12, and when I turn it on, what happens? Test point 2 goes down to 0. So that's pull down. So again, a lot of you probably remember this from the other video I did. This wanted to refresh some memories, or a video you can look at. I go into more depth. But that's what I need to determine, and we'll go and we'll look at why I care about that. Okay, so let's look at the circuit and see what type it is. So if you look at this, the control can't be after, because here's the ignition coils, and they go straight to ground. There's no control over here. The control is before the load. This is the load. Do we remember what type of circuit is switched before the load? Right, pull up. When the circuit is not energized, it's at 0, and when it's energized, it's at 12 volts. So given that, now that I know the ignition system was a pull-up design, that means the ignition control wire wasn't being grounded. Let's think about that. If this was being grounded, what would happen? It would blow a fuse, because there's no load between that and the ground, right? So that wasn't happening. No fuse is being blown. Like in the Focus, if you remember, the short was down here. It's after the load, so it's not going to blow anything, but it just fried the coil, because it just had massive amounts of current go through it for too long. But that wasn't the case here. He has a pull-up design, and if he was grounding over here, since it's before load, it would blow a fuse. It was not. So it wasn't that. Bummer. So I said, wow. So now I have to determine why was this spark plug not firing. I was just coming up with some ideas. Flaky PCM. Maybe the fire killed it. Maybe the PCM wasn't receiving the necessary inputs. Crank or CPS. But after research, the RX-7 doesn't have a cam. So that can't be it. It's only crank. Maybe they're just defective coils. Maybe they haven't been changed since the fire and the heat just cooked the insulation and they're shorting inside, right? It could be an internal wiring harness issue. Maybe the fire caused some insulation to melt and they're touching each other or something. Or it could be external to the harness where it's something is touching the frame or touching another wire. Don't know. I have to look. But that's what's going through my mind. Potential things to look at. He sent over what his coil was like. And the reason I wanted to show this is I decided to let's attack the coils first. We'll go right to the coils. So I put around the coil trigger, I put I back probe the coil trigger to see a voltage. And on the coil power, I put an amp clamp. So what I'm expecting to see on the scope is the following, right? When it's not being energized, I expect to see the control to be at 0 volts. And when it's not energized, I expect to see the current ramp at 0, right? No current's flowing. And once I see the control being pulled up, I expect to see current in a nice ramp. So again, this is what I expected to see. I expected, so each time the crank was in a certain position, the PCM would control the coil. Remember, from here to here is dwell. Remember, that's in another video. That's the dwell time, meaning once the control goes back down to 0 is when the spark plug actually fires. I expected to see a current ramp. I expected no straight up edges. Again, real quick, for a more technical explanation of these forms and current ramp, I suggest purchasing Scanner Danner Premium. He does a spectacular job. That's beyond the scope of this, but just giving a general overview, that's what I was expecting to see. Each control should have a current ramp. Well, I set you up. If you see this diagram, that isn't what was happening. Unfortunately, I don't have the real traces. We found it so quickly I didn't have time to set up my camera. I apologize, so you'll have to go with this. But needless to say, I was seeing control, but I wasn't seeing current ramp. So no current was flowing through the primary. So what's that telling us? It's telling us that the PCM was able to control the ignition coil, no question. But for some reason, the primary wasn't pulling any current. But it was intermittent, did you notice? Sometimes it worked, sometimes it didn't. So it could be a bad coil, vibration causing to happen, maybe a bad ground somewhere, right, in the igniter. Bad power, maybe it had a broken wire or something, or had wiring issues as well, right? Well, what was interesting is this is the connector that goes into the coil from the PCM. If I just would grab that and move it up or down or side to side, I could make the current ramp occur or not occur. Well, there it was. We found the issue. It was a bad wiring harness. So we disconnected the wiring harness. So this goes to a main connector, and then these plug into the 4 ignition coils. So remember, there's 2 before and 2 after in the RX-7 engine. And when we benched it, many of the wires had connectivity issues. So we knew it was bad. So he got with the manufacturer, and I believe they sent him out another one, or gave him a substantial reduction in price to a new harness. So it's a fix. This is definitely one of my favorite slideshows. I just love solving car issues. We had so much fun doing this. He was so happy. He now felt he could drive his car confidently. And as of time of this video, he's gone already 400 miles without one ignition issue. So he's more than happy. And then he took me for a ride in this bad boy, and it sticks to the road. It's RX-7, right? Those things that run on rails. It's a very nice car, and my favorite part of it is hearing the turbo spool up as he was accelerating. I don't know if you guys know this, but I love force induction, but that will be for another video. Thank you for watching. I hope you found the information helpful.